As I've been preparing this mini lecture, I've been trying to figure out how to frame the Earth's subsystems without sounding like I'm reciting the opening to the 90s cartoon Captain Planet, or for the younger members of the class, maybe Avatar: The Last Airbender. But approaching the physical systems of our Earth by splitting them into more elemental categories is a really useful teaching tool. It makes intuitive sense because we often categorize natural experiences this way, whether that's with the air we breathe, or the water we drink, the earth we walk on, or the living organisms that we share the planet with. So in this video, we will define the Earth's spheres or subsystems, and then we'll talk about how they interact to produce the Earth as a system. This will be part mini lecture video, but also an overview of our next 14 or so weeks together. Going forward, each sphere will be the topic of a module or two, along with the project modules that help tie them together. A sphere refers to a subsystem that makes up part of the Earth. They're named after the shape of the Earth, a round object. And scientists use this metaphor a lot for different systems, but the four big ones we tend to focus on in introductory physical geography courses are the atmosphere, the hydrosphere, the lithosphere, and the biosphere. We're going to go over them briefly now, but just remember we'll go a lot more in detail in the coming weeks. The atmosphere is the air that surrounds the Earth. Atmos is Greek for vapor, smoke, or steam. It contains the mixture of gases needed to sustain life on Earth. And the atmosphere is kept in motion by the uneven heating of the Earth's surface and by the Earth's rotation. So this might sound familiar from our last video. That same uneven heating that causes the seasons also causes air currents and wind. The hydrosphere is water in all forms. Hydro comes from the ancient Greek hudor, for water. The oceans contain most water found on Earth, and they're also the source of most precipitation, like rain. And water can also be found in its frozen form as ice. The lithosphere is the solid inorganic part of the Earth. Lithos is Greek for stone. So this includes the rocks of the Earth's crust, so that outer layer, and also the loose mineral matter that overlies solid bedrock. The lithosphere is shaped into diverse landforms on both land and underwater. So think mountains, canyons, islands, coastlines, that kind of thing. And last but not least, the biosphere includes both the parts of the Earth where life can exist and the life forms that exist upon it. Bios is Greek for life. So we can think of the biosphere as a space, but it's also the living beings in that space. And so far, these subsystems may seem pretty separated, but once we start observing them, we can spot the ways that they interact. In the same way that the relationship between the Earth and the Sun is based on energy, as in solar radiation, similar is true of the spheres. They exchange energy and matter through cycles. We can see energy in the Earth system as movement or the capacity for movement, as heat or light or stored in matter. And matter is the stuff that makes up stuff. It's anything that has a mass or an amount and a volume, meaning it takes up space. We saw this in the last lecture video when we talked about greenhouse gases. Those carbon dioxide molecules are matter. They have mass, though each molecule is quite small, and they have volume, though they spread out quite finely as a gas. And taking carbon as our example, we can watch it move through different spheres. So carbon is stored in plants. It makes up their structure like leaves, stems, roots, etc. And carbon is also stored in humans when they eat plants or when they eat other animals that eat plants. So that's the biosphere, right? Living organisms. Carbon also gets stored in the lithosphere, including as fossil fuels. So, for example, coal comes from the remains of ancient plants. It's carbon trapped underground and compressed into a dense rock. Sometimes humans dig up that coal because it releases energy when it's burnt. So this part should sound familiar from the last video when we talked about greenhouse gases. When we humans breathe, we release carbon dioxide into the air or atmosphere, and this also happens when we burn coal. Some of that carbon dioxide, of course, hangs out in the atmosphere, but some of it gets breathed in by plants. They use that carbon dioxide in their process of photosynthesis, which is how plants make their own food. They turn the carbon into sugars and then release the oxygen, that dioxide part, back into the atmosphere. And this is the same oxygen that we humans and other animals breathe. So we've just watched carbon cycle through 3 spheres: the atmosphere as carbon dioxide in the air, the lithosphere as coal, and in the biosphere in the bodies of plants and animals, including humans. Sometimes cycles between the spheres can get out of balance. This happens during a feedback loop, which is when the outcome of a cyclical process changes the strength or frequency of that process. One example has to do with albedo, which we covered in the last lecture video as well. Albedo, as a reminder, is the percentage of sunlight that is reflected by a surface. Now, ice has a pretty high albedo, something like 50 to 70% of sunlight gets reflected. And our planet's ice caps, those huge areas covered by ice around the North and South Pole, reflect a lot of incoming light, and that helps keep the planet from getting too warm. But the other 30 to 50% gets absorbed and then radiated back out as heat, like any other surface. Of course, as the planet heats up due to more greenhouse gases in the atmosphere, that ice is starting to melt, and it's being replaced by what's underneath. In some areas, it's land, and in others, ocean. But both have a lower albedo than ice does, meaning the land and ocean surfaces absorb more sunlight, and they radiate it back out as heat. So maybe you see where this is going already. That heat melts more ice is replaced by more land and ocean surface, and those surfaces absorb and radiate more heat. So it ends up as this vicious cycle, one that has already started, but hopefully can be prevented from getting worse. And we'll come back to this when we talk more about climate change and environmental justice. But for now, we can see how this specific feedback loop, called the ice albedo effect, connects the hydrosphere, which includes ice and the ocean, the lithosphere, which includes land, and the atmosphere, through which heat travels by radiation to melt the ice. So we've followed matter and energy between the spheres. This can give the impression that though the spheres are connected, they have discrete boundaries, meaning they seem to be perfectly separated. But that's more of a division that humans have made to better explain the spheres. In reality, the spheres have these fuzzy boundaries, meaning that they overlap or they shift into each other. We can look, for example, at this map of a barrier island in Alaska. It's showing us through these colored outlines the change in the shoreline of this narrow island. We might say this is a pretty distinct cut between the lithosphere, the sand, and the hydrosphere, the sea. But what causes this change from 1984, the purple lines on the inside, and 2023, the yellow lines on the outside? The shorelines on barrier islands, like this one in the map, are extended by the movement of water, by waves and ocean currents carrying sand along the coast. So the shoreline is really an interaction between the two, but it's not separable into two spheres. Instead, it's produced by both. This shoreline is both lithosphere and hydrosphere. And this is just one example, but in pretty much any natural phenomenon, we can find air, water, land, and or living beings shifting into and out of each other. We'll go more in depth on each of the spheres in future weeks, but up next is our first map making project. These projects take the place of exams in this course and are a bit more involved than the selfie field trips. First, we'll be making maps that connect our personal lives with the four spheres, and we'll be focusing on our commutes or other trips and connecting them to the environment. Then we'll reflect on the practice of map making and the experience of sensing the environment with our bodies. And this will start next week. Thank you for watching and see you next time.